All right, you have a block, 30 kilogram block, moving to the right, sliding on a surface with constant velocity. You are pushing down on it at an angle of 25 degrees downwards, and the applied force is 80 newtons. The force of your push is 80 newtons. You're not pushing it horizontally, you're pushing it down to the right and down. We're looking for the kinetic friction and the normal force. First thing is to draw a force diagram. Dot. There's the weight. The normal force will be longer than the weight. Make it longer because you are pushing downwards with an applied force that has an x component to it, F-A-X, and a downward component, F-A-Y. And that angle is 25 degrees. And then the static friction is not opposite the applied force, it's opposite the direction of motion, which is opposite F-A-X. So, whoopsies. So that's your kinetic friction. That matches F-A-X, not F-A. The normal force balances not just F-G, but F-G plus F-A-Y. So you have to go off to the side and calculate these two. Right? F-A-X is adjacent to the angle, and so F-A, which is 80, so this is, the hypotenuse is 80. So 80 times the cosine of 25 degrees, and I've already done that. It came out to be 73. And in the y-axis, it's opposite the angle, so you use sine. So 80 times the sine of 25 degrees, and I've already done that one. It's right over here. That came out to be 34 newtons. So to solve the problem, you'll find the kinetic friction in the x-axis. Net force in the x-axis is equal to 0 because although it's moving, it's not accelerating. Therefore, the kinetic friction equals F-A-X, which we just calculated to be, what, 73 newtons. In the y-axis, net force in the y-axis equals 0. There are three forces in the y-axis. Normal force pointed up, and that's balancing the two downward forces, the weight and F-A-Y, not F-A, but F-A-Y. So the weight is 30 times 9.8, which is 294. 294 newtons. That's the weight. 30 kilograms times 9.8. That gives you the weight. 294 plus FAY is 34. Add them together, and you get 328 newtons. All right. You're done. Normal force 328, kinetic friction 73.